So we're going to start. So first, I'll start with an introduction of myself. So I'm Hadad. I'm an application attack and penetration SME at EU Advanced Security Center in Israel. My main role in EY is performing application penetration testing and research, mainly for iOS applications and client and native applications and product assessments. These are my details, and the project that you're about to see is a part of EY's internal R&D program. So, what are we going to talk about today? So today we are going to talk about iOS applications, more specifically about iOS view controllers. First, we will discuss what view controllers are exactly, and we will ask, why do we care about this? And that is, why do we care first as penetration testers? How can we use view controllers? And from the security aspect of development, why is understanding view controllers and what you can do with them is important? Then we will discuss view controllers hierarchy, and let me tell you this. If there are any iOS developers here, for you, this part is going to be boring, okay? So it will be about 10 minutes about view controller hierarchy, and then we will move on to controlling view controllers. Afterwards, we will discuss about Scrapper, which is an automatic tool to control view controllers. And then we will discuss the mitigations for the damage that you can do by controlling view controllers. So, like every good presentation, I will start with a famous saying. It goes like this. I'm sure you all know it. One automatic tool can save you tens of hours of working manually. But a good approach can save you hundreds of hours of working with an automatic tool. Now, honestly, I just made this up, okay? But it is true. So the main focus of this talk is really not about the automatic tool at the end of it. It's really about the approach. The approach of performing higher level operations to do interesting things and not always focusing on the lower level just when it is needed. So view controllers. What are view controllers in general? We'll go in depth later, but just generally. So generally, view controllers group together a set of components in iOS applications. So if you have an iOS application, it has several components, and the view controllers group those components together. They also are in charge of the code that is related to those components. The codes, the methods, the functionalities. Often view controllers correlate to a single screen. For instance, if we look at this picture, so all the red boxes in this picture can be view controllers. The screen itself, or what wraps those red boxes, can be a view controller as well. What that means for us as an overview is that view controllers actually define boundaries between the application's functionalities because they group together the application's components and the related code. Again, we'll go in depth later to this, but if view controllers define the boundaries between the application's functionalities, that can mean a lot to us as penetration testers. Why is that? Well, first of all, if we can find all the view controllers in an application, that can help us a lot with reconnaissance. Because when you think about it, if we can have a list of all the application's view controllers or groups of functionalities, we can know everything that the application does. We can know what we should focus on, what we should focus on more, what we should focus on less. But more than that, if we can control the view controllers that, as we said, correspond to components in the application, we can perform client-side controls bypass. Let's just focus a minute on what I am saying that we can do with this. I'm talking about iOS applications. It's not something that I claim is supposed to help with, I don't know, kernel exploits or anything that is related to the operating system. We are focusing here on client-side. It's not server-side attacks. And when we talk about client-side, you can divide it to two types of attack vectors, which is bypassing restrictions or attacking other users. So this is about bypassing restrictions. But how can we do that? So a lot of the times when we want to do runtime manipulation to bypass restrictions, what we are actually trying to do is one of the two things. Either get away with something that doesn't let us continue to a more privileged, more interesting screen or component, or we just want to load a certain interesting screen or component. That can be an authentication or registration screen. Some screen that requires to put in license or some kind of a token validation. Maybe we want to load administrative screens. And even getting away with jailbreak detection is relevant here. And I can tell you that all of these things we could do just by tampering view controllers. Because if you can tamper the view controllers, you may be able to just load the desired components or get away with the ones interfering us. And even if you do need to execute a specific method, you need to do something a little more lower level than just loading components. If you can control the view controllers, again, that will help you a lot with focus, because we have said that view controllers also group together the related code of those functionalities. So instead of looking through methods and the entire application, you just need to load a specific view controller and search the method there. Once you can do all this, of course, that can help you with other types of attacks as well, because if you can load an administrative screen, you can find different servers that you didn't know they exist, or maybe even attacking other users. So when I think about it, you are all already here, so I don't need to persuade you into this, so I can just move on. View controllers. To understand view controllers, it's better to first understand MVC. So MVC, I'm sure that most of you heard about MVC, and maybe most of you also know what MVC is, so we will go through this briefly. So MVC stands for Model View Controller. MVC is a development pattern, meaning it's a pattern that developers and frameworks use when designing their code. The goal of this pattern is to separate between the model, the view, and the controller. The view is all those things that are presented to the user. Now in UIKit, which is the framework that is usually used to develop iOS applications, usually the view is also referred to all those things that the user interacts with. So that can be buttons, switches, text labels, input fields, all of those things are part of the view. The model is all of those things that are behind the scenes. The data structures of the application, files, the logic of the application, the flow, the interactions with the device. All of those things are part of the model. The controller is responsible for interacting between them. So a common way to describe model view controllers, and I will say that there are a lot of variations to MVC, but Apple states clearly that UIKit still is based on the classic MVC in a way. So you can see that there's the view here. Sorry, just a second. There's a view here, and the view is responsible of always displaying the model. The view is supposed to present the model at any given moment. When something happens in the view, requests are sent to the controller, which is in charge of updating the model accordingly. And the controller is also in charge of rendering the view, of presenting it. Quick example. If, for instance, we have the settings application, which we will use a lot in this talk as an example. So there's the airplane mode switch, which is a part of the view. And when a user clicks on the airplane mode switch, what happens is that the switch changes its state, but first only at the view and not the actual state of the airplane mode in the device. So what happens after the switch is being clicked? A request is being sent to the controller, an update that the airplane mode button was clicked. The controller is in charge of manipulating the model to actually start airplane mode. That's really briefly and putting it in the simple way, but that's enough for this talk. So more specifically about view controllers. So now that we know all about MVC, we can be more accurate and say that view controllers actually bundle together a few view components in the application. How they do that is they store a reference to the root view object of these components. There's a root view object which contains all the views of this component, and the view controller has a reference to that root view object. They are also in charge of presenting those views, as we said that controllers are, and they also handle the interactions, meaning they execute the code that is related to the interactions with this view. They are also in charge of communicating with other view controllers. Programmatically, when a developer wants to develop a view controller, usually what's needed is to extend a base class which is called UI view controller. It is provided by UIKit, and the reason it's important is because this class contains all sort of properties and methods that are important for view controllers. For instance, things like load view, which is in charge of presenting or loading the views before they are presented to the user, methods that are instantiating the view controllers, and these kind of things. So there are two types of view controllers in general. One type we've sort of discussed, which is the content view controller. It's a view controller that handles a single bundle of views and is responsible of presenting them, taking the interactions, these kind of things. That's the content view controller. Another type of view controller is the container view controller. So the container view controller is actually responsible of containing other view controllers. So there will be a containment relationship that looks something like this. You have the container, which will be the parent of the view controllers it contains. And that container will have other view controllers as children. Those children can be, for instance, content view controllers, and they will be the ones that are responsible of actually presenting the content. So the content is presented by content view controllers. Container view controllers are responsible for containing other view controllers. So, as we said, they are responsible for presenting the view controller's views, and they do that by presenting the root views. There's a parent-children relationship, and some common types of container view controllers, we will see some examples ahead, are, for instance, UI split view controller, UI navigation view controller, and UI tab bar controller. Similarly to UI view controller we've seen earlier, the UIKit's base class of view controllers, these view controllers are base classes for container view controllers. The content view controller, as we said, it extends UI view controller, and you have the container view controller, which will usually extend a base class of container view controllers, like UI tab bar controller, and that base class also extends the base class of UI view controller. That's an example of an inheritance tree of container and content view controllers. So examples of container and content view controllers. That's a split view controller. So in here we see at least, there's actually more, but in here we see at least 3 view controllers. How do we know that? Is because we know that there are 2 sort of screens, we can say sub-screens here, one on the left, one on the right. So this is presented with a split view. So there has to be another view controller which contains them and is responsible for that split view. That container will be the split view controller. This type of view is relevant more for iPads and not iPhones. So that's an example of a split view controller. Navigation view controller is a view controller that contains other view controllers in a navigation stack. It enables to navigate between view controllers without closing them. So we can present at a given moment a view controller and store in the navigation stack other view controllers and just swap between them without closing them. One last example, UI tab bar controller. I think we all know this, when we have tabs that we can tap on, and those tabs replace the views that we see. So what actually happens is that there's a container view controller, which is a tab bar controller, and that controller presents different view controllers as the content controllers. But actually, it's a little bit more complicated than this, because there's a containment tree. What that means is that containment can be nested. Container view controllers doesn't have to contain content view controllers. They can also contain container view controllers. So that would mean that the application has a tree of view controllers at a given moment. Now, at any given moment, the application can have only one containment tree. It has only one tree with one root, which is called the root view controller. So the root view controller actually contains all the other view controllers that are currently loaded in the application. A reference to the root view controller is stored here. And this is an example of a containment tree. So we can have the root view controller as a container view controller, which is UI tab bar controller. It can contain other containers, such as navigation view controllers. And these can contain, the tree doesn't have to be even. One can contain a container, the other can contain only content view controllers, and only the ones on the green are the ones that actually display the application's content. Now let's see how we can examine this tree at runtime. So again, the settings application as an example. And let's say we want to start digging into the tree of this example and see how the container and content view controllers are organized. So in this example, I'm using scripts. Some pronounce it script. It's a tool for iOS that enables to inject commands at runtime to iOS applications, if someone doesn't know it. It's sort of a console for iOS applications. So what we see here, okay, yeah, you do see it, good. So what we see here is that we have the root view controller, which is called PS split view controller. Now this name is probably preference settings view controller or something like that. So by the name, we already know it's probably not the content view controller, which is displaying the content. But we can check that, for instance, by climbing up the superclasses tree. So when we check the superclass of this view controller, we do see that this view controller is a split view controller. So it's not a controller that displays content. If we continue on to look for the children of this view controller, because it's a container, we see that this controller contains a navigation view controller. So that controller's child is actually another container, a navigation view controller. So if we continue on to look for the children, we see that this child view controller contains a view controller which sounds like the one displaying the content, because it's called preflist controller. Sorry. And if we try to find an indication that this view controller is actually a content view controller, we again can climb up the superclasses tree. First, we see actually that it doesn't have children, which is already sort of an indication that it's a content view controller. It doesn't have to be, but we can also climb up to the superclasses tree, and we see two things. We see that two superclasses ahead, there's a superclass which is still custom. It's not a UI kit superclass. It's called PS view controller and not UI something, so it's still a custom superclass. But if we go up just one more, we see it's a UI view controller and not some kind of a container. So we know that that's probably a content view controller, which is the one displaying all the content that we see. What happens if, for instance, we click on Control Center? If we click on Control Center, we see that another screen appears. And let's try to examine the changes that occurred within the view controller's tree. So now we see that the navigation view controller we have seen earlier has another child, which is called PSUI prefs root controller, which has another child, which is a content view controller. And that child is called control center, which is probably the one displaying the control center. So that would be an example of how we can examine the current tree in the application, the current tree of view controllers in the application we are working on. One more thing about view controllers, hierarchy, is that view controllers can do something that is called a modal presentation. Modal presentation of view controllers means that a view controller can display on the top of itself another view controller. Any view controller can do this, also content view controllers. And I think this is the key difference. There are some nuances, but a content view controller can also display other view controllers by this method, a modal presentation. Now, the view controller that is presenting another view controller modally can also dismiss this presented view controller. So a mid-summary about view controllers hierarchy. So to sum this up, view controllers are responsible of managing a set of views in the application and their respective model, meaning also the code of these components. They can also contain other view controllers, including containers, and they can present another view controller modally. This is a quick list of some useful commands for view controllers and the examining of view controllers. You can take this list and use it after downloading the presentation. So now the main question that remains is, how do we control view controllers? So controlling view controllers. So first, what controlling view controllers means is that we could swap view controllers that are not currently loaded in the application. So the first thing, of course, that we need to do is find those view controllers. So the first question is, how do we find view controllers that are not currently loaded? So there are several possible approaches for this. First approach would be to look for nib names. Nibs are files that contain configuration of views among the rest of view controllers, or of the classes names. For instance, look for ones that contain view controller in them. It is easy to find, but the main problem is that first, there's no context. For instance, let's assume that the application has like 150 view controllers. So if we have a list of 150 view controllers, sometimes often a lot of them won't have any meaningful name, and a list of 150 things without a meaningful name doesn't mean a lot. And second of all, it's not extensive, because what if our view controllers does not contain view controller in their name? So that's an approach a lot of tools take, but we see those are the problems with it. Another approach will be to look for subclasses that are subclasses of, look for classes that are subclasses of UI view controller. It is extensive, but again, the main problem is that there's no context. Another approach would be asking the storyboards. What are storyboards? Briefly. Storyboards bundle together view controllers. In general, each storyboard is supposed to represent a logical flow within the application. It can be the login flow or the main functionality of the application. It can be the settings. It's actually the developer's decision. In theory, you can use one storyboard for the entire application, which is not recommended, or use a storyboard for each screen, which is also not recommended. Most of the developers don't do this. Now, storyboards contain a map of the view controllers with their matching nib files, which we said contain their configurations. This is the reference to that map. So the question is, how will we enumerate the storyboards? That one's easy, because storyboards has matching storyboard C file. So all we need to do is go through the file system of the application and find the storyboard C files. So sort of a summary of the phases to enumerate view controllers using storyboards would be this. First, we need to enumerate the storyboards using the files. Then we will need to retrieve the nib files from the storyboards, for instance, using this reference. Then we will need to instantiate the relevant view controller that we have found. You can use methods like init with nib name. And then we'll need to present it. Now, that's a lot of phases. But even though it's a lot of phases, we can do it automatically with a tool such as Swapper. So Swapper is a tool that is supposed to do all those things that we have just seen automatically. What it does is, first it's written in Bash and it uses script, the tool that we have mentioned earlier. It enumerates the view controllers of the application using the application storyboards. And then it displays the storyboard and then it displays the view controllers by the context of the storyboards. Then it lets you load the desired view controller or dismiss the desired view controller. It also stores a log file of the view controllers of the application. Now, to understand a little bit better the strength of using this type of method, let's recall what would be needed to bypass a certain client-side restriction. Let's say, for instance, we have a screen that performs jailbreak detection, and all the regular tools of jailbreak detection doesn't work. So we need to perform some kind of a runtime manipulation. What will we do then? We might do something like this. This is a classic way of doing this. We'll need to class dump all the classes and the methods of the application, which today is not such an easy thing to do, always. We'll need to search for the relevant methods, maybe trace those methods using a tool such as Frida, write an injection script to those methods, and hopefully, if that works, we might succeed. But if you use a tool or an approach that only goes for the view controllers, the only thing you might need to do is choose the relevant controller, and that's it. You're there. You have bypassed the client-side restriction. You have fully loaded the component you need instead of trying to find methods that do this for you. Now, I'm not saying that this will entirely eliminate the need for runtime analysis. But for the cases that it will do this, it can spare a lot of time and a lot of work. So how do we use Swapper? For example, we will see one example later, but how do we use Swapper? We have the name of Swapper, and then we need to put in the process ID or the process name. Then Swapper will present a numbered list of the view controllers with the context of the storyboards. As we said, this is very important because this gives the context of the view controllers and the functionality. Then you just enter the storyboard number dot the view controller number, and it loads it. If you want to dismiss the storyboard, you enter D, and the view controller is dismissed. So this is an example of how Swapper's output looks like. You have here the storyboards, 0, 1, 2, 3. These are the storyboards. These are the view controllers. And we see that a lot of the time view controllers have names that are not very indicative. So this is how important it is that it will display it in the context of storyboards. Now, this application that you see here is the vulnerable iOS application. And in this case, this is a Swift application, so it also works with Swift. Let's see a video of a demonstration of how this actually works. If that can actually work, then we can see the video. We'll give it a few more seconds. If it doesn't work, then okay, that works. Great. So, as you can see, you just load Swapper with the application's name. And then the video stops. And then it continues, good. Scrapper shows you the list of the storyboards and the view controllers. You just, on the right you see the application. So you just put in the storyboard number and the storyboard number and the view controller number. And on the right, you can see that the view controller is loaded. So that's how easy that is. The storyboard dot view controller, and it loads the relevant view controller. So let's see a few examples of what you can do with this method, with this approach. This is, for instance, an application which has jailbreak detection. And I can tell you that this application has jailbreak detection that some of the best tools of jailbreak detection, like Liberty, could not have bypassed. So we have looked through this application, and we've seen that good tools for jailbreak detection could not bypass this. So what we did is just we used Scrapper. We entered the D to dismiss the presented view controller, and we could use the application. So just imagine how much work it would be in relation to D enter to start performing runtime analysis on this. And as an evidence, if the best tools couldn't have bypassed this yet, that means there's a lot of work to do. Because if it wasn't such a lot of work, they would already do this or add this to their tool set. Another example would be administrative screens. As we said and promised, we've also found these types of things. It's obfuscated because it's a client of ours, and responsible disclosure reasons we cannot show the exact application, but you can see here that we have reached a screen that is called server configuration. It enabled us to choose the environment of the application, swap from production environment to test environment or stage environments, these kind of things. I do not need to say why development environments are something that is very sensitive, both if you don't want others to know what you're working on right now, and both because development environments a lot of times have a lot of vulnerabilities. And additionally, we could enable all of the application's functionalities even though it was supposed to be allowed only to privileged users. This is just one example of an administrative screens. We had a lot of others, and actually a lot of applications, for some reason, tend to store administrative screens which are related to environment, to the ability to replace environments. But not only that. So how do we get Swapper? First, you need to wait a bit. I do plan on releasing it soon. You can follow me on Twitter to check when. I plan on informing when I do so. And the only question remaining now is, how could this be prevented? As a developer, how could you prevent the damages that can be done by doing this? First of all, completely refrain from developer backdoors, meaning administrative screens or all sort of screens that are not supposed to be client-side. If it's not supposed to be client-side, we will find them. So just don't do this. If we're talking about bypassing a certain authentication screen or something like that, that is supposed to be meaningful in a well-designed application, because sensitive data is always supposed to be stored server-side anyway. So if you do not store sensitive data client-side, never ever, so that would mean that even if an attacker can bypass a certain screen, he's not supposed to find anything. If there is some kind of functionality or the application is supposed to be post-payment, whenever you can, just use the App Store. That's why it exists. But if you can't, and it's a client-side control that has to be enforced client-side, like jailbreak detection, so what you need to do, first, if it's only client-side, of course, that an attacker would always be able to bypass this. But if you want to make it harder for attackers, then what you need to do is you can, for instance, wrap all of your methods that load view controllers or screens with some kind of a checksum that you need to do in order to perform this action. So to sum up, if you're a pen tester, tamper with view controllers. That can spare you a lot of time. If you're a developer, beware of pen testers that do this, because it is possible, as you could see. And if you're a researcher, always try to abstract lower-level operations in order to make everyone's life easier. That's what I was trying to do here. I would like to thank you for participating, and I hope you've gained something from this talk. And we do have a few minutes for questions. Any questions at all? I can't hear you, sorry. Am I going to release Clapper? Yeah. Yeah. I might even put it on GitHub so others can contribute and change it if they want. Yeah. Anything else? I think that's it.
All right. Thank you very much to Tomer.
Thanks a lot, everyone.
Do you want to do the selfie challenge as well?
Sorry?
Do you want to do the selfie challenge as well?
Yeah.
Got a phone to do a selfie?
Where's that?
You want to use your phone? Do you want to use your phone?
Okay.
Okay, if you don't want your face to be shown, then no, with the audience. Do it with the audience. Everyone smile or hide your face. You look like having a good time. Excellent. Thank you very much, Tomer.